Hi everyone. Jamie from Stony Brook University, and Tristan, the next speaker, is also here, and we're collaborators. Also, today I would like to give my talk about antioxidants mitigate the toxicity of lunar dust simulants. First of all, I would like to give everyone a brief intro of lunar dust, although I know there was a lot talking about this in previous speakers. But basically, lunar dust is composition-wise, it's composed of silicon oxide, and it's similar to terrestrial dust. And in the case on Earth, not on Moon though, in the case on Earth, it is the terrestrial dust can cause silicosis or other chronic pulmonary diseases in miners and other constructors or so. And but the lunar dust can be worse because there's no atmosphere on Moon. So lunar dust is directly exposed to, say, space radiation, solar wind, and the bombardment of meteorites. And also in the report from Apollo mission, it is found to be finer, and astronaut experiencing more irritating in respiratory system, and also runny nose, like red eyes or so. And they also commented that it can go everywhere, so it will be really dirty. Because there's a plan to go back to Moon in the United States, so we hypothesize that occupational exposure to lunar dust could lead to DNA mutations and mitochondrial dysfunction. Mitochondria is the organelle that's important for energy production in cells, and mitochondria is also affected by DNA. So if the DNA is going wrong, you won't have energy, and the cells may die and experiencing different kinds of damages. And when the cells are damaged and not repaired, it would lead to elevated cancer risk or other chronic disease risk. So for our lunar dust simulants, we use LHS1 and MS1, and those simulants are bought from manufacturer that's synthesized from terrestrial minerals. And after our purchase, our collaborator like Tristan, the next speaker, would do cell size exclusion and grind them to around 10 micrometer to make sure it's fine enough to simulate what's the actual size on Moon. And then some of them would be treated with hydrogen gas for simulating the effect of solar wind, which is space weathering, which is an aspect of space weathering. And then for most of the time, we store the samples in the vacuum desiccator. Before our experiment, we'll take it out from the vacuum desiccator and grind it up again, and then we'll apply for lung cells. Because as I previously said, those astronauts in Apollo missions kind of stress that they have experienced more allergic effect or inflammatory response in the respiratory system. So that's why we choose lung cells for our model to see if lunar dust simulants or lunar dust could cause damages in cells. So first of all, there's some preliminary results. From here, you can see that the reduced samples, which is like simulating the solar wind, the aspect of solar wind, we can see that the survival rate for both simulants are a lot more lower than the untreated one, which is the regular one, not reduced from the hydrogen gas ones. And you can see for both does it's significantly decreased. So that makes us really kind of intrigued that why is that? So first of all, we looked at the mitochondrial reactive oxygen species, because when there is a high burden in RS and mitochondria, it could lead to different dysfunction and stuff leading to cell death. So we used a dye to verify that, and we have found out that after the exposure to the lunar dust simulants, there is a increased signal for the mitochondrial RS, and we also quantify here. And you can see after the exposure to the two dust, it's both has a significant response. And next, because mitochondria function is highly related to mitochondrial DNA and nuclear DNA, so we also look at the DNA product, and we found that the DNA is also significantly decreased. For nuclear DNA, we use another assay to confirm that, because mitochondrial proteins are encoded by nuclear DNA too. So we can see that the nuclear DNA is also highly damaged after exposure to lunar dust simulants. So the longer the tails, the higher the damage, which this essay is aiming to show us. But unfortunately, we still don't know like what the exact mechanism of how lunar dust could lead to damages in cells. There was a review paper hypothesizing that the free radicals would be the reason of that, but we're not exactly sure. So that's why we're using NAC, which is an important antioxidant to cells that would neutralize the effect of RS to verify if RS is really the main role that would lead to cell death or damages in cells. So RS is a pretty important inflammatory signal. So if there's an increase in RS, it could lead to inflammation, and inflammation can cause damage to tissues and thus causing cancer. So in our preliminary results, we also found out that after the pretreatment of NAC, the survival is increased for both dust simulants, and the mitochondrial DNA is also increased after the integrity is also increased after the exposure to the dust particles. So which means that NAC did neutralize some damaging effect of RS that's probably induced by the lunar dust simulants. Lastly, I'll give you guys a brief conclusion because there are a lot of details I didn't mention, but feel free to raise any questions. So in my study, we found out that there's an increased toxicity to cells, increased toxicity to mitochondria, which is the powerhouse that will generate energy in cells. And there's also increased damage to DNA in cells after the exposure to the two lunar dust simulants. And the reduction of both minerals, so just to kind of stress that again, the reduction is to simulate the solar wind, which is the space weathering effect on the moon. The reduction increased their toxicity, and free radicals seems to have an important role in the toxicity of lunar dust simulants to cells. And lastly, because we're still not sure the exact mechanism, and we're looking at this enzyme called NADPH oxidase, which will generate RS. There are a lot of reasons of generating RS, but we're just suspecting this would be the main effect, and we'll go ahead and verify that in a couple of months, and we'll find out like that if it's the main kind of protein that's responsible. Okay, thank you for your attention.
All right, and with that, we have about 2 minutes for questions, and I did see one in the chat. If astronauts are protected by their suits, do they still need to worry about DNA damage?
Yeah, I would think so, because in the Artemis program, it clearly stated that it would be like a routine exploration on the moon. So, like air pollution, it may be below the kind of the standard that the government has stated, but the long-term exposure of those particles could still lead to cancer. So if air pollution can be a problem, then I think for the chronic exposure to lunar dust, which is far more toxic than the dust on the Earth, can still be a problem for astronauts in the future in the Artemis program.
Excellent. And we have time for one in-person question. Go ahead.
Sure.
Have you done any size grain dependence on damage?
I'm not exactly sure because I'm more on the bio side. Probably Tristan, the next speaker, could answer that question. I'm sorry, but thanks for your question.
Okay, thank you.